Hello everyone, this is Upal Purohit and I welcome you all to my YouTube channel. Now my dear friends, as you can see here the topic is coordination chemistry. So we are going to talk about what exactly coordination chemistry is all about, what it is going to incorporate. Right? So obviously, as the name suggests, coordination chemistry. In chemistry it's all about compounds. So we need to think about from a particular sense, and that is coordination chemistry is all about study of coordination compounds. But then let us start from scratch. What exactly this particular compounds are all about? So to begin with, my dear friends, please remember one thing, and that is when I have two or more stable compounds, okay, that is two or more stable compounds, and if they are undergoing a combination, then this results in the formation of molecular compounds. It results in the formation of what? Molecular compounds. So what we can now talk about is molecular compounds are those compounds which are being formed by combination of two or more stable compounds. Now these molecular compounds, depending upon the combination, are of two types. The first one we talk about, and they are called as double salts. What are they called as? Double salts. अब दोस्तों नाम से ही समझ में आएगा आपको, डबल का मतलब होता है दो, ओके, और हम बात करेंगे यहाँ पे salts. Now remember my dear friends, when I talk about salts, it's very simple. Those are compounds which are being made up of a cation as well as anion. मतलब positively charged as well as the negatively charged ions. इसका जब combination होता है और जो मुझे compound मिलता है, that compound is called as what? Salts. And those are two such compounds, and therefore I call these as what? Double salts. Okay, simple words. Now अभी double salts actually क्या होता है? And that is, obviously they are molecular compounds which are going to be stable only in the crystalline state. अपने crystalline state में वो stable रहेगा, या what we call it as a solid state. But then it completely decomposes. Completely, ये वर्ड पे मैं स्ट्रेस कर रहा हूँ, it completely decomposes, या फिर हम बोलते हैं breaks, when it is dissolved in water or any solvent which has an ability to dissolve. Not necessarily always it is water. Of course, whenever we talk about solvent, the first thing which comes into our mind is water. लेकिन water is not the only solvent, my dear friends. ये आप जानते हो अच्छी तरीके से. और जनरली हम जब सॉल्ट्स की बात करते हैं तो सॉल्ट्स में चार्जेस होता है, पोलैरिटी होता है. जनरली वाटर इज अ पोलर सॉल्वेंट, और इसलिए हम लोग जनरली वाटर के बारे में बात करते हैं. लेकिन वाटर के अलावा भी बहुत सारे सॉल्वेंट्स होते हैं जिसके पास अगर ये काबिलियत है इस डबल सॉल्ट को डिसॉल्व करने की, तो जब ये इसमें डिसॉल्व हो जाएगा इस सॉल्वेंट में, तो क्या होगा, वो पूरी की पूरी तरीके से बिखर जाएगा, पूरी की पूरी तरीके से वो डिकम्पोज हो जाएगा, कंप्लीटली ब्रेक्स into its constituent ions. Constituent का मतलब तो आप जानते ही होंगे, जिसका वो बना हुआ है, that is called as constituent ions. Okay, these salts are made up of ions. So the ions from which this particular salts are being made up of, those are called as what? Constituent ions. So I have a compound in a solid state, it's going to be stable, but then when I'm going to dissolve it in an appropriate solvent, it breaks down. Okay, and that is going to give you what? The constituent ions. Now, I'll just make this concept very clear, and that is by giving you an example. Okay, let us take an example of potash alum. Now, potash alum is going to be formed by interaction of K2SO4 with aluminium sulfate, that is Al2SO4 thrice. Along with that, there are going to be 24 water molecules. Okay, so these are going to combine. As I said, the two or more stable compounds are going to combine. Now combination is related to its proportion, what we also call it as a stoichiometric ratio. Okay, or stoichiometric proportion, which we call it as. So in a proper stoichiometric ratio, K2SO4, Al2SO4 thrice and 24H2O combines, and that gives you potash alum, and that potash alum can be given as K2SO4 dot Al2SO4 thrice dot 24H2O. Now I hope you understood the significance of this dot. Yes. डॉट का मतलब क्या होता है? दे आर ऑल गोइंग टू कंबाइन एंड दे आर गोइंग टू बी एग्जिस्टिंग टुगेदर. तो ये सॉलिड स्टेट में ये स्टेबल रहेगा. लेकिन जैसे ही दोस्तों इसको मैंने डिसॉल्व किया इन एन एप्रोप्रिएट सॉल्वेंट, व्हाट एम आई गोइंग टू गेट इज K plus ions, SO4 2 minus ions and Al3 plus ions. Okay, now if I ask you a very simple question, my dear friends, and that is कि ये पोटाश एलम कौन से आयंस का बना हुआ है, the answer which you get is going to be potassium ions, K2SO4 का. Next one is sulfate ions, which are present in K2SO4 as well as Al2SO4 thrice, and of course aluminium ions, that is Al3 plus ions. और वही आयंस मिलेंगे, देखो दोस्तों, जब हम उसको सॉल्वेंट में डिसॉल्व करेंगे. यानी इसका मतलब ये हो जाता है, what we can now talk about is कि these compounds, which compounds? Yes, double salts are going to have its own identity, are going to have its own stability when only it is in the crystalline state. जब भी वो सॉलिड स्टेट में होता है तो उसके पास उसकी एक पर्टिकुलर आइडेंटिटी होती है, एक पहचान होती है, लेकिन वो अपनी पहचान खो देगा जब वो उसे डिसॉल्व किया जाएगा इन अ एप्रोप्रिएट सॉल्वेंट. आई बात समझ में? नाउ वी गो इनटू द नेक्स्ट पार्ट. नाउ जैसे मैंने आपको बोला है, मॉलिक्यूलर कंपाउंड्स आर गोइंग टू बी फॉर्म्ड बाय द कॉम्बिनेशन इन एप्रोप्रिएट स्टोइकियोमेट्रिक रेशियोज ऑफ टू और मोर स्टेबल कंपाउंड्स. तो उसमें वन ऑफ द टाइप ऑफ मॉलिक्यूलर कंपाउंड्स इज डबल सॉल्ट्स. अब नेक्स्ट है, हम उसको बोलेंगे दैट इज कॉल्ड एज कॉम्प्लेक्स कंपाउंड्स. सो वी गो इनटू द नेक्स्ट वन एंड दैट इज कॉम्प्लेक्स कंपाउंड्स. अब जब हम कॉम्प्लेक्स कंपाउंड्स की बात करेंगे तो व्हाट वी आर गोइंग टू से ओवर हियर इज that these are the molecular compounds which are going to retain their identity. Okay, वो अपनी पहचान बनाए रखता है even in the solution state. Okay, even in the solution state. Okay, I hope you understand the word solution state. When a solid gets dissolved in a solvent, the resulting solution which I am going to get is called as what? A solution state. Alright? So, यहाँ पर मैंने क्या लिखा है? Retain their identity even in the solution state. Even का मतलब तो जानते हो, यानी solution state में भी वो अपनी identity पहचान बनाए रखता है. इसका मतलब solid state में तो वो stable है ही. It has its own individual properties. लेकिन solution state में भी वो अपनी identity बनाए रखता है by formation of or by forming at least one complex ion. By forming what? At least one complex ion. Okay. Now I give you an example so that you understand this very well, and that is I have got KCN. It combines with FeCN twice. Okay, and that gives you K4 FeCN6. Okay, it gives you what? K4 FeCN6. Now, if I want to just balance this reaction, I'll just write it down as 4KCN. Okay. Now, when I dissolve this in an appropriate solvent, तो मुझे क्या मिलता है? पोटेशियम आयन, which is a simple ion. लेकिन उसके साथ साथ मुझे मिलता है FeCN6 4 minus, which has an altogether different property as compared to the Fe ions as well as cyanide ions. यहाँ पर FeCN twice है. ओके, सो अगर मैं इसको और ब्रेक करूंगा तो मुझे मिलना क्या चाहिए था? फेरस आयंस एंड साइनाइड आयंस, लेकिन नहीं मिलता मुझे. ओके, ये Fe एंड साइनाइड दे आर गोइंग टू एग्जिस्ट टुगेदर एंड एज अ रिजल्ट ऑफ विच इट फॉर्म्स इट्स ओन इंडिविजुअल सेट ऑफ प्रॉपर्टीज, जिसे हम लोग क्या बोलते हैं? कॉम्प्लेक्स आयन बोलते हैं. और इसी वजह से बिकॉज ऑफ दिस कॉम्प्लेक्स आयन, इसके वजह से नहीं दोस्तों, ओके, इसके वजह से, ये कॉम्प्लेक्स आयन बनने की वजह से हम क्या बोलते हैं कि इट इज गोइंग टू रिटेन देयर आइडेंटिटी. और ऐसे कंपाउंड्स को हम लोग क्या बोलते हैं? जी हाँ, हम बोलेंगे उसको कॉम्प्लेक्स कंपाउंड्स. ओके, सो प्लीज माय डियर फ्रेंड्स, जस्ट हैव अ लुक एट इट वंस अगेन. व्हाट आई वाज टॉकिंग अबाउट इज दैट when we are going to discuss about the initial stage, two or more stable compounds going to combine in an appropriate stoichiometric ratio, resulting in the formation of molecular compounds. And there are two types. पहला है डबल सॉल्ट्स, दूसरा है कॉम्प्लेक्स कंपाउंड्स. डबल सॉल्ट्स वो होते हैं जहां पर हम इसकी स्टेबिलिटी की बात करते हैं सिर्फ और सिर्फ क्रिस्टलाइन स्टेट में, लेकिन जब उसे डिसॉल्व किया जाता है इन एप्रोप्रिएट सॉल्वेंट वो अपनी पहचान खो देता है. Okay, and it gives you a constituent ions. That means it gives the ions from which it is made up of. And I give you a simple example of potash alum, where it breaks down into its constituent potassium ions, sulfate ions, and the aluminum ions. The other category of a molecular compound is going to be complex compound. Those are the molecular compounds which will retain their identity even in the solution state. And that is why how it is going to be forming is, and that is by formation of a complex ion. I give a simple example, and that is KCN being reacting with ferrous cyanide. It gives you K4FeCN6. Now K4FeCN6 breaks down to give you a potassium ion and FeCN64-. Now FeCN64- is a complex ion. It has got properties altogether different from those of the constituent ions, and therefore it is the one which is responsible for retaining the identity. और इस तरीके से जो K4FeCN6 है हम उसे क्या बोलेंगे, complex compound. Okay, so I hope you have understood this. Now what I will do is, in just brief, okay, whatever I have discussed so far, मैं उसे क्या करता हूँ in a formation of a table, differentiation way, मैं आपको इसका exact differentiation बता देता हूँ between double salt as well as complex salt, so that this particular concept becomes absolutely clear to every one of you all, that what exactly is the difference between the complex compounds as well as the double salts. So here we go. This comparison we talk about, and that is, on one side I'm going to write down double salts, and the other side we are going to write down complex compounds. So the major points of difference, so that this becomes a type of tabular revision of what we have discussed so far. Only stable in crystalline state. Okay, यहाँ पर we are going to say is stable even in the solution state. I will understand the difference now. यानी सिर्फ सॉलिड स्टेट में है, यहाँ पर सॉल्वेंट के साथ ट्रीट होने के बाद भी वो स्टेबल है. कंप्लीटली ब्रेक्स in the solution state into its constituent ions. Okay, into its constituent ions. यहाँ पे it's going to undergo a partial decomposition or partial breaking in presence of the solvent, resulting in the formation of complex ion. Okay, and thus retaining the identity in the solution state. Okay, now the next part is, we are going to say is, the properties are similar to those of the constituent ions, because ये सॉल्वेंट में पूरा का पूरा डिसॉल्व हो जाएगा. Okay, पूरा का पूरा ब्रेक हो जाएगा, completely breaks into its constituent ions, so it is going to lose its identity. यहाँ पर मैं लिख देता हूँ, it's going to lose its identity. Okay, यहाँ पर मैंने क्या लिखा है? It is going to retain its identity. So properties therefore are similar to those of the constituent ions. यहाँ पर मैं बोलूँगा कि the properties are different. Than those of the constituent ions. इसीलिए तो मैंने लिखा है in the previous points कि वो अपनी पहचान बनाए रखेगा. Okay, example तो मैंने आपको ऑलरेडी बता दिया है. Okay, if you want I can just give you once again an example, and that is potash alum, K2SO4, Al2SO4 thrice, dot 24H2O. यहाँ पर मैं आपको example दे सकता हूँ, that is K4 FeCN6. There are n number of examples my dear friends, but then जो मैंने अभी consider किया उस हिसाब से मैंने लिखा है. तो आप देख सकते हो my dear friends, now in this particular tabular format the differentiation between the two, you can very well understand what exactly is the difference between the double salt as well as complex compounds. So I'm sure you have understood this concept very well.